Hey, the next thing we want to do with our ants, we have them finally in the world, wandering around randomly. I want to see if I can get them to go home. So my program today should be, I have these ants, and they're wandering somewhere, but I want them to say, can I easily get back home? So let's see if we can program that up here. So let's make another method down here called home move. That is going to take me, I'm not going to do random move anymore. Eventually I'm going to say self.home move. Can I go home? Well, I remember where home is and where that position is. It would be nice to be able to figure out the distance between two positions, two places. Let's just make that a general function. I'm going to use it. I might want to add more things to this later, and so let's go make a general function. Now I'm using some code here that is in other Mesa models. I've been interpreting and gathering things from a lot of other Mesa models as I go. This one is directly from something else, and somebody gives me two positions. I want to be able to return the basic Euclidean distance. So x1, y1 equals position 1 from position 1, x2, y2 from position 2. The difference in the x is equal to x1 minus x2, the dy is equal to y1 minus y2, and then return my classic Euclidean formula. Square the individuals and then put them together. So I'm going to need math for this. Let's import math while we're here. And this will give me the distance from my position to the home position, or any position to any other position when I use it. Okay, so let's use that down here to figure out what's the best way to go home. Let's go get the neighbors. Now my neighbors, I'm going to get them in a very similar way that I did for the environment. The environment went out and got all the neighbors. Let's just go get all of those neighbors in the environment, and then I'm going to calculate the minimum distance between all those neighbors. So my minimum distance is going to be the minimum of this list of distances. Go get the distance from self.home position to the position for each position in neighbors. Okay. I'll make this a little bit easier to see here. We don't need all those. Okay. So I have now minimum distance. There might be more than one spot out there that is the same distance. So let's get all those positions for each position in neighbors. We're going to go through it again, and we're only going to keep final candidates if the get distance of the position to pause is equal to that min distance. Okay, now I have all of my potential neighbors. Let's shuffle them up. These are the closest people, and then, hey, model grid, move the agent to the first one. At random, I'm just going to pick that one. Okay, so Now my ants should go home every time they're supposed to move. Let's see if I broke anything in making that. Looks like I can still step. Everybody doesn't move at all. They are home, and everywhere around them, the closest thing to do is to be there. It doesn't really demonstrate our case yet. Let's go back to the model setup and not put them at home. So before we move them, we're going to say, hey, ant, your real position is, say, 12, 44. Okay, and I'm going to place that agent at 1244, and let's see if they can go home. Ah, there's our ants. Let's see if they start to go home. They're not. Okay, let's figure out what happened. Why are these ants not going home? What's happening out here? Ah, I have a misspelling in my position calculation. Okay, so back here in the agents, pause 1, pause 2. Ah, yes, you were probably watching along knowing that I did that. And so let's see what happens here. Ah, that looks better. I have these agents out here. Step. Oh, something happened here. Why did I get an environment object? When I passed in pause 2, the error comes back, cannot unpack environment object. Ah, pause 2. What am I calling this down here? Get distance for pause in neighbors. But neighbors, when I copy and pasted, is an environment thing. I want to say, well, really, I want to have their positions. Yes. And now I have neighbors is a list of positions. Oh, look at them. They're moving. Let's just start the simulation here. They are going home. Great. And then they're moving out just a little bit because they've got some random moves. Everywhere else is close. This is good. Okay, they never pick their home spot. You never look at the spot where you are, and so you're always moving somewhere and then moving right back. Okay, we got these agents to move home. Good. And we could pick different starting positions for them over here in the model. We could say, let's put them at 42, 44. Oops. That is not going to be happy because I don't have the world thinking of them in the same place that the agent thinks of them in, but they were still able to gravitate their way home. They're just visualized in a different place. Ah, they're over here now. Good. Let's get them to move home here. Great. Okay, so our agents can now wander home. The third piece we want to add next time is getting these agents to wander toward the gradient of the pheromone. And once we have these 3 movement pieces, then I can start to build their program.